In the cosmic abyss, the weight of black holes. A wondrous chronicle of time, an era that unfolds. Strokes of light, the touch of darkness. Mysteries embedded in the past, secrets of the future's harness. The cosmic dance floor, a ballet of starlight. Silhouettes of time, our steps in the night. A dazzling night sky, a stage of enigma. We are but a chapter in the living universe's drama. Today, I will introduce an alternative theory to resolve the paradox of black hole information, known as the holographic principle. This principle, independently proposed by Gerard, Hooft and Leonard Susskind in the 1990s, suggests that the event horizon of a black hole plays a role similar to a hologram. In holography, a two-dimensional surface encodes a three-dimensional image. Observing the surface of a hologram allows us to perceive a three-dimensional image. According to the holographic principle, the event horizon of a black hole is analogous to a two-dimensional surface. This surface encodes all the information generated within the black hole's interior. The holographic principle is considered crucial in resolving the paradox of black hole information. This paradox arises from the contradiction between the need to preserve information of objects falling into a black hole and the fact that information cannot escape from the black hole's interior. According to the holographic principle, all information generated within a black hole is encoded on the event horizon. Therefore, when a black hole evaporates, the information encoded on the event horizon returns to the universe. The holographic principle posits that spatial volume can be considered an encoding of information on lower dimensional boundaries, such as the boundary of light. This principle is a theoretical postulate of string theory and a presumed property of quantum gravity. In the context of black hole theories, the holographic principle plays a significant role. The event horizon of a black hole is considered a two-dimensional surface. According to the holographic principle, all information within the black hole is encompassed on this two-dimensional surface. The holographic principle holds promise in resolving the paradox of black hole information. If all information of a black hole is encoded on a two-dimensional surface, then when the black hole evaporates, this information can return to the universe through that two-dimensional surface. ADS, CFT duality. ADS, CFT duality, proposed by Juan Maldacena in the 1990s, represents a duality between a five-dimensional anti-de Sitter space, ADS space, and four-dimensional conformal field theory, CFT. ADS space is a five-dimensional space with negatively curved spacetime, while CFT is a quantum field theory occurring in four-dimensional spacetime. This duality plays a crucial role in understanding the thermodynamics of black holes. Black holes are considered to play a role similar to the boundary of ADS space in the context of ADS, CFT duality. Therefore, using ADS, CFT duality, we can gain insights into the thermodynamics of black holes. ADS, CFT duality is closely related to the holographic principle. According to the holographic principle, the volume of three-dimensional spacetime can be encoded on a two-dimensional surface. ADS, CFT duality provides a method to implement such holograms. While ADS, CFT duality is not fully understood, it is believed to play a significant role in the future study of black hole theory. ADS, CFT duality corresponds to the relationship between anti-de Sitter, ADS, space and conformal field theory, CFT. ADS space is a five-dimensional spacetime with negatively curved geometry, and CFT is a quantum field theory with a four-dimensional boundary. ADS, CFT duality serves as an example of the holographic principle. The information in ADS space corresponds to the information in CFT. Thus, ADS, CFT duality aids in explaining the holographic principle in black hole theories. ADS, CFT duality can also assist in resolving the paradox of black hole information. According to ADS, CFT duality, information within a black hole is contained in ADS space. Consequently, when a black hole evaporates, this information can be transmitted to CFT through ADS space. The significance of the holographic principle in ADS, CFT duality and black hole theory. The holographic principle and ADS, CFT duality play crucial roles in black hole theory. These principles can potentially help resolve the paradox of black hole information. Additionally, they may aid in understanding the internal structure of black holes. While the holographic principle and ADS, CFT duality remain theoretical and not completely understood, They are expected to have a substantial impact on the future research of black hole theory. The holographic principle and ADS-CFT duality are two fundamental concepts in black hole theory. The holographic principle suggests that information in three-dimensional space can be encoded on a two-dimensional surface. This principle was discovered in the early 1990s as scientists explored the thermodynamics of black holes. Black holes, as gravitational anomalies in spacetime where nothing can escape, are known to emit heat. Researchers studying the thermodynamics of black holes found that the entropy of a black hole is proportional not to its volume but to the area of the event horizon. This implies the existence of infinite information inside a black hole. According to the holographic principle, this infinite information can be encoded on the two-dimensional surface of the event horizon. In other words, all information within a black hole can be observed through the two-dimensional surface of the event horizon. ADS-CFT duality is a form of holography that deals with the correspondence between a three-dimensional quantum field theory, CFT, and a five-dimensional anti-de Sitter space, AD space. Discovered by theoretical physicist Juan Maldacena in 1997, this duality suggests that the information in a three-dimensional quantum field theory can be viewed as existing on the boundary of a five-dimensional AD space. ADS-CFT duality is closely related to the holographic principle. In ADS-CFT duality, the quantum field theory in three-dimensional space is considered as being on the boundary of a five-dimensional space. Therefore, information in the three-dimensional quantum field theory can be encoded on the boundary of the five-dimensional AD space. In the context of black hole theory, the holographic principle and ADS-CFT duality are believed to be crucial in resolving the paradox of black hole information. According to these principles, information within a black hole is encoded on a lower dimensional surface, allowing for a potential understanding of the fate of information when a black hole evaporates. Both the holographic principle and ADS-CFT duality hold promise for advancing our understanding of the enigmatic nature of black holes and their underlying physics. According to the holographic principle, all information within a black hole can be encoded on the two-dimensional surface of the event horizon. Therefore, the paradox of black hole information can be resolved by explaining how the two-dimensional surface of the event horizon changes when the black hole evaporates. ADS-CFT duality signifies a correspondence between a three-dimensional quantum field theory and a five-dimensional quantum field theory. Thus, it is possible to model the information inside a black hole with a three-dimensional quantum field theory. It is expected that through this modeling, new methods for resolving the paradox of black hole information can be discovered. Both the holographic principle and ADS-CFT duality are concepts that are not fully understood yet. However, these two concepts are believed to play crucial roles in black hole theory. Further research is expected to deepen our understanding of these concepts. The holographic principle and ADS-CFT duality are both essential concepts in black hole theory. The holographic principle proposes that the volume of three-dimensional spacetime can be encoded on a two-dimensional surface. This principle is considered crucial in resolving the paradox of black hole information. ADS-CFT duality involves a duality between a five-dimensional anti-de Sitter space, AD space, and a four-dimensional conformal field theory, CFT. This duality provides a relationship between the thermodynamics of black holes and quantum field theory. The holographic principle and ADS-CFT duality are related to the simulation theory. Simulation theory posits that the universe we inhabit might be a computer simulation. While this theory is not scientifically proven, it has captured the interest of many people and has been explored in science fiction. According to the holographic principle, the three-dimensional volume of spacetime can be encoded on a two-dimensional surface. Although the method to implement such holograms is not yet known, computer simulation could potentially achieve this. ADS-CFT duality provides a relationship between the thermodynamics of black holes and quantum field theory. This connection can be utilized in simulating black holes through computer simulations. Therefore, the holographic principle and ADS-CFT duality can be interpreted as evidence supporting simulation theory. Of course, whether simulation theory is correct remains unknown and unproven scientifically. It is a hypothesis suggesting that our universe is a computer simulation, and the holographic principle and ADS-CFT duality offer theoretical bases that align with this idea. Simulation theory suggests that the universe we live in might be a computer simulation. While this theory lacks scientific evidence, it has become a popular theme in science fiction movies and novels. The holographic principle and adds CFT duality can be presented as evidence supporting simulation theory. According to the holographic principle, the three-dimensional volume of spacetime can be encoded on a two-dimensional surface. This principle might imply that our universe, following the holographic principle, could be a three-dimensional world generated from a two-dimensional surface in a computer simulation. Adds CFT duality also aligns with simulation theory. According to this duality, the quantum mechanics of a five-dimensional space is equivalent to the quantum field theory in a four-dimensional space. This principle might suggest that our universe, according to ADS CFT duality, could be a simulation with hardware and software components. The holographic principle and ADS CFT duality are concepts that are not fully understood yet, but they can be presented as theoretical evidence supporting simulation theory. Simulation theory proposes the hypothesis that the universe we inhabit is a computer simulation. This idea remains unproven scientifically but has inspired various science fiction works. The holographic principle and ADS CFT duality can be seen as providing evidence supporting simulation theory. According to the holographic principle, the three-dimensional volume of spacetime can be encoded on a two-dimensional surface. This principle implies that our universe might be a simulation, where the information of the three-dimensional world is encoded on a two-dimensional surface. ADS CFT duality is also relevant to simulation theory. It suggests an equivalence between the quantum mechanics of a five-dimensional space and the quantum field theory in a four-dimensional space. This idea may indicate that our universe, following ADS CFT duality, could be a simulated reality with specific rules encoded in its structure. While the holographic principle and ADS CFT duality are not fully comprehended, they can be interpreted as theoretical foundations supporting the concept of simulation theory. According to the holographic principle, the three-dimensional volume of spacetime can be encoded on a two-dimensional surface. Following this principle, all the past and history of humanity could potentially be encoded on the event horizon of a black hole in the form of infrared radiation, neutrons, or other forms of energy. Of course, this is still a hypothesis, and extensive research is needed to resolve the information paradox of black holes. However, if true, black holes could serve as colossal databases storing the history and culture of humanity. When a black hole evaporates, this information might return to the universe. While this possibility is fascinating, it remains speculative until further investigation occurs. The straightforward answer to this question is, yes. Black holes are places where spacetime is severely warped, and nothing can escape, potentially allowing for the storage of all of humanity's past and history. However, a more nuanced response is perhaps, the information stored in a black hole must adhere to known physical laws. Therefore, even if all of humanity's past and history were stored in a black hole, it might not be encoded in a way that we can read or understand. Information stored in a black hole could take various forms. Infrared and neutrinos. Particles like infrared radiation and neutrinos can pass through a black hole. Therefore, all of humanity's past and history could be projected onto these particles and encoded in a black hole. 2. Quantization of information. Information is quantized, divisible into minimal units known as bits. Even if all of humanity's past and history were stored in a black hole, it might be divided into extremely small units. Holographic principle. According to the holographic principle, three-dimensional information of spacetime can be encoded on a two-dimensional surface. Humanity's past and history might be holographically stored on the event horizon of a black hole. None of these hypotheses have been scientifically proven, but they provide essential clues for resolving the information paradox of black holes. If the holographic principle holds, the three-dimensional volume of spacetime can be encoded on a two-dimensional surface. According to this principle, all of humanity's past and history could be stored as a hologram on the event horizon of a black hole. This hypothesis is still speculative, and resolving the information paradox of black holes requires further research. The question of whether all of humanity's past and history is encoded in a black hole remains an open topic for future investigation. Several hypotheses exist regarding the information paradox of black holes. Information destruction. This hypothesis suggests that information within a black hole is destroyed, meaning that when a black hole evaporates, the information of objects it consumed is lost forever. Many physicists find this hypothesis problematic as it violates information conservation laws. Information preservation. This hypothesis posits that information within a black hole is preserved. Consequently, when a black hole evaporates, the information of objects it consumed returns to the universe in some form. While compliant with information conservation laws, this hypothesis lacks a clear explanation of how information is preserved within a black hole. Information transference to another dimension. This hypothesis proposes that information within a black hole is transferred to another dimension. When a black hole evaporates, the information of consumed objects might manifest in a different dimension. Although lacking scientific evidence, this idea remains intriguing. The fate of information inside a black hole is yet to be fully understood, and these hypotheses contribute to ongoing efforts to resolve the information paradox. The paradox of the black hole, the paralysis of information. A symphony of simulation, the echoes of the final judgment. Worlds where gateways open to dimensions untold. A cosmic intersection where reality and dreams unfold. The cosmic pathway leading to portals. Endless alleyways of spacetime's stellar corals. A realm where existence and non-existence entwine. A labyrinth of information, a puzzle in the design. Within the gaze of the black hole, distortion of time. The chaotic moment nearing the ultimate truth of the cosmic prime. Thrills in the multiverse, the faint future of judgment. Our destiny shrouded in mysteries profound and abundant. Dreams scattered at the infinite gateway. A nostalgic journey into the embrace of the cosmic array. The information of the black hole, the paradox of dimensions. In the cosmic puzzle, we encounter profound revelations.